the last video we were talking about what we want to solve for and how we're going to use equation number 1 and equation number 2 to solve for the charge. So all we want to do is substitute. We want to solve for K using equation number 2. When we solve for K using equation number 2, we get K is equal to mg over the fall velocity. And if we want to solve for Q, we just substitute this in. This implies that QE is equal to mg over the fall velocity plus mg. Seems like I'm leaving something out. Oh, times VR. So let's go ahead and let's just continue on. So now we can take that mg out. We can factor it out. And we end up with VR, or the rise velocity, over the fall velocity plus 1. Okay. So let's just write this a little bit neater. I'm going to take this over here. I'm going to say QE equals to mg. Let's see here, and we had the, make sure I have this right, we have the rise velocity over the fall velocity plus 1. And now let's rewrite this. Let's just multiply 1 by 1. That's going to be the fall velocity over the fall velocity. So when you multiply 1 times 1, you just get 1. So we end up with mg times VR plus VF all over VF. Now if we're going to solve for the charge, we just say, because this is QE, we just multiply both sides by the electric field, and Q is going to be mg VR plus VF all over VF times E. So this is the equation that we're going to use. In the next video, we are going to get into how we calculate the mass. All right. And you know what G is. Okay. G is just 9.81 meters per second squared. We know what E is. We know how to calculate that. It's just going to be the voltage over the distance of the separation of plates. And we will find the rise velocity as well as the fall velocity utilizing video physics. But in the next video, we are going to discuss how we're going to calculate M. Okay?